We are in the last section of chapter 12 where we get to use the recursive rule to find different sequences and functions. Uh, Up to this point, what we've been doing with sequences, especially by identifying a pattern to some nth term, is we've been able to use just one value in order to find whatever pattern it is. Uh, that's useful for when we are looking for some nth sequence like a sub 20 or a sub 40 or something to that extent. For the recursive rule, you have to use one or more preceding terms in order to find the pattern in the sequence. So you cannot be able to use like to find a sub 20, but you would have to find other values in the sequence to get up to that point. So it's used mostly for trying to find like the first X amount of terms in a different sequence, and I'll show you what I'm talking about with the examples. So if we have examples A and B here, for A, they tell us that a sub 1 is -2, and then the general equation for a sub n is um, a sub n equals a sub n minus 1 plus 3. So in order to find the next value in the sequence, you must plug in the preceding value and then add it to 3. So they want us to find the first 6 terms here. So I'm going to go a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So a sub 1, they give us. It's -2. A sub 2 is we have to use the value from a sub 1 because here it's a sub n minus 1. Well, n in this case is 2. 2 minus 1 is 1s, but a sub 1 was -2, so I have to say that -2 plus 3, and then that's going to equal 1. Same thing goes for a sub 3. I have to use the one preceding, so it's going to be 1 plus 3, which is going to equal 4. Same thing goes here. I got to use the preceding one, so it's going to be 4 plus 3, which gives me 7, and then 7 plus 3, which gives me 10. I got to go to what, a sub 6, I guess, for 6 terms. So that's going to be what, 10 plus 3, which gives me 13. So the values in this sequence, the first 6 values are -2, 1, 4, 7, 10, and 13. So this is where you had to use another value in the sequence in order to find the pattern of the sequence preceding it. So like I couldn't find a sub 20 because right away, because in order to find a sub 20, well, I'd have to find a sub 19. Well, to find a sub 19, I'd have to find a sub 18, and so on and so forth. So for B, again, we want to find the first 6 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So they give us the first 2, so it's going to be -5 here, and it's going to be 2 here. And then a sub n is dictated by, it's 2 times 2 values preceding it, and then it's adding to the sequence that the value that was prior. It's because, so if I go to a sub 3 here, it's 2 times, and it's going to be n minus 1. Well, if n is 3, 3 minus 1 is 1, so it's going to be multiplied by the -5 plus a sub n minus 1, which just gives me a sub 2, which is added to 2. And in this case, -10 plus 2 is a -8. Same thing goes for here. I got 2 times, so I got to go 2 values. So it's going to be a sub 2, which is 2, plus the value for a sub 3, which is -8. So 4 plus a -8, that's going to give me a -4. And here it's going to be 2 times -8 plus a -4, and that equals a -20. So I'm just using the preceding values that they tell us in my sequence with the general equation. So I got 2 times, this is going to be 2 values, that's negative 4, plus a negative 20, which is going to give me, what, a negative 28. So the pattern in this sequence is going to be negative 5, 2, negative 8, negative 4, negative 20, and negative 28. There's going to be occasions where they're going to ask you to write a recursive rule for each of the sequences. First step that you're going to want to do is identify if the pattern is either arithmetic, geometric, or neither. If it's arithmetic or geometric, there's a certain equation that we can write. So if it's arithmetic, we can write that the general equation is going to be a sub n equals whatever the a sub n minus 1 will be plus by the common difference of d. That's going to be the general equation for being able to write any recursive rule for an arithmetic sequence. If it's a geometric sequence, so this I'll just write arithmetic right here. And then if it's geometric, it's going to be a sub n equals whatever the common ratio is, so that's going to be r times it by a sub n minus 1. So that's going to be the general equations for those two patterns, if that's what it so has for each sequence. If it has neither of those things, then we have to kind of do a little guess and check. And let's take a look at A. So A, the sequence is 140, 16, 32 fifths, 64 25ths. Let's take a look and see if it's, it doesn't look like it's going to be arithmetic. It doesn't look like you're going to have a common difference there. So let's take a look and see if it's going to be geometric. So if I take 40 divided by 100, that gives me 0.4. 16 divided by 40 gives me 0.4. 32 fifths divided by 16, that's 0.4. I'm going to go on a limb and say that it is geometric, and then the common ratio here is going to be 0.4. So since I know that it's a geometric sequence, I can then use my general equation that I was given here and write it as a sub n equals 0.4 times it by a sub n minus 1. So for B, let's take a look and see if it's geometric first. So let's say 28 divided by 8, that gives me 3.5. 48 divided by 28 gives me 1.7. So it's not geometric. So if I go find if it's arithmetic, so I go 28 minus 8 gives me 20. 48 minus 28 also gives me 20. And 68 minus 48 is also 20. So this one is a arithmetic sequence with the common difference being a positive 20. So that means I can just use this equation here to help me write my recursive rules. So this is going to be a sub n equals a sub n minus 1 plus d, which is 20. Okay? The next two, I'll let you in a secret, neither of them are geometric or arithmetic. So what we have to do is take a look and see what the pattern is. So what I'm going to do is I'm going to say, okay, a sub 1, I got a sub 2, a sub 3, a sub 4, and a sub 5. So this is going to be negative 10. This is going to be 8. And this is going to be 18. And this is going to be 10. And so we got, this equals negative 8. So from here, I want to pay attention to these two values right here. So I got negative 10 and I got 8. How can I manipulate those numbers either using addition, addition or subtraction, or multiplication or division? How can I take negative 10 and 8 and make 18? Well, what I can do is I can say that 8 minus a negative 10 will equal 18, which means that I took a sub 2 and subtracted by a sub 1. So if I say that, okay, my a sub n in this recursive sequence is going to be a sub n minus 1 minus a sub n minus 2, so it's going to be the value preceding it minus two values preceding it, will give you whatever a sub n is. So like if I look at a sub 4, I can say that, all right, so that means that I have the one right after, it's going to be 18 minus two values after that, which is going to give me 8, which equals 10, which holds true, checks off. And then if I go 10 minus 18, it's going to give me a negative 8, which it holds true. So this is my general equation for this particular sequence. A lot of it is guess and check. It's probably not the most scientific or mathematical way to do it, but sometimes it's the most logical. For D, I have a sub 1 equals 1, a sub 2 equals 1/2, a sub 3 equals 1/6, and let's say a sub 4 equals 1/24. So it seems like there's really no rhyme or reason for the pattern. So, but actually what I was able to find out, so if I go a sub n would equal, if you take the value preceding that, which is a minus 1, and then you divided it by n, that'll help you find the pattern. So if you look at this one here, the one preceding that is 1 divided by n, which is 2, that gives you the 1/2. This one here, you go to the value preceding that, which is 1/2, divided by 3. 1/2 divided by 3 gives me the 1/6. Here, 1/6 divided by 4 gives me the 1/24. Checks out. Again, this is a lot, some of it is guess and check. I wish it wasn't that way, but sometimes it is. Last thing is we have what is called the Iterate compositions of functions, where we want to find the first three terms, which is x of 1, x of 2, and x of 3 through the following functions. So if, like for A, they give us f of x equals 5x minus 3, and they tell us that x of 0 equals 1. So how I can figure out what x of 1 is doing this. I can say, okay, x of 1 equals the function of x of 0. Well, x of 0 is 1. So I can say, all right, x of 1 equals, put it into the function, 5 instead of, so then my x I put as 1 minus 3, which then will give me 2. So x of 1 is 2. To find what x of 2 is going to be, I use the function of x of 1. So x of 2 is going to equal 5 times this value for 2 minus 3, which is going to equal 7. So here's x of 1, here's x of 2. X of 3 is the same thing. I'm going to find the function of x of 2. So x of 3 here is going to be 5 times 7 minus 3, which is going to equal 35 minus 3, which is what? 32. And so the first three values are going to be 2, 7, and 32. If I'm looking for B, they tell us that x naught, or x of 0, is negative 1. So I can say that to find x of 1, just like here, I'm going to say f of x of 0. So then x1 equals negative 1 squared minus 1. Well, that's going to give me positive 1, so this is going to be 1 minus 1, which gives me 0. So then to find x of 2, I got to find what the function of x of 1. So x of 2 is going to equal 0 squared minus 1, which gives me negative 1 again. And then lastly, x of 3 comes from the functions of x of 2. X of 3 equals negative 1 squared minus 1. Well, negative 1 squared is 1. 1 minus 1 is 0. So this function is going to be 0, negative 1, 0. In fact, this pattern kind of goes 0, negative 1, 0, negative 1, all the way to infinity. And that is being able to use the recursive rule for sequences and functions. Hope this helps. Until next time.